recording this, and for those that came in late, I was asked what were the topics for our exam, and here they are: competition, monopoly, monopoly cartel, Cournot, Stackelberg, and externalities. So what about externalities? So hopefully you all watched the introductory externalities video. I don't know if anybody has any particular questions about it, because we could start there. But when we talk about externalities, we're just, again, exploring the first fundamental welfare theorem. The first fundamental welfare theorem says that competitive markets are efficient, but in order for competitive markets to be efficient, right, we have to have no externalities, no market power, and some condition on the way information is shared. So a lot of people will say it's perfect information or symmetric information, and then we have the criteria satisfied, right? So I guess it's important to say that, you know, competition isn't only a price-taking equilibrium. That's important, but our real kind of issue is, you know, when will price-taking get us to an efficient outcome, meaning to maximize net social benefits? So, and that's what the first fundamental welfare theorem tells us, is we can't have any externalities. That's one of our conditions. So in order to talk about efficiency when there are externalities, it helps to have like a really simple case. And so normally the simple case would look something like this. Now, remember, the demand curve has a bunch of different names, right? And you know, you have to get familiar with the jargon. You know, using a particular name for demand it depends upon, you know, the point you're trying to make. It's just like if you're talking about a dog, right? You might call it a dog, or you might call it a mammal, or you might call it a quadruped, depending upon what you're trying to express, right? What's meaningful in a context. So remember that, so our demand is, we could refer to it as, you know, the willingness to pay curve. That would be fine. But here what we're emphasizing is that it's the marginal benefit curve, okay? And for supply, again, we're emphasizing that it's the marginal cost curve. And so everything looks good here, and then we have this price-taking equilibrium, and we have efficiency. But there's really kind of a lot that's hidden that you have to talk about in a little bit more general context in order to understand what's happening with externalities. Well, with externalities, there are either hidden costs or hidden benefits, and a lot of times we'll talk about a hidden cost as a negative externality and a hidden benefit as a positive externality, but it's just external costs or external benefits. And so the key idea is that efficiency always happens, okay, where marginal social benefit is equal to marginal social cost. That's the socially optimal quantity. We often call that Q double star. Okay. And the competitive equilibrium, or I'll say the price taking equilibrium, is identified by a different set of equations that are closely related. And the price taking equilibrium always happens where marginal private benefit is equal to marginal private cost. And you would call that quantity Q star. And the point of the first fundamental welfare theorem is that, when the first fundamental welfare theorem is satisfied, then we know that Q star is equal to Q double star. And otherwise, in general, right, we don't have an expectation that they will be the same. So in this classic setting where I just have marginal cost and marginal benefit, what am I really talking about? Well, this is the price taking equilibrium that I've identified, and I can go ahead and put down here, right, where demand and supply intersect. That's the price taking equilibrium. That's Q star, right? Oh, I need a different color. And if there's no other information, right, we think the first fundamental welfare theorem is satisfied. Okay. So then that's, and this is what we haven't been explicit about, marginal private costs and marginal private benefits. Well, whose private costs? Well, they're the costs that are borne by the producer. Okay, that's their private cost. It's the costs that they see when they're running the business, right? The marginal private benefit are the benefits of consuming the good that go to the particular consumer that's consuming it. It's their private benefit, okay? So, but when we have externalities, and again, the easiest case to talk about is the case where, and this is the classic one, the one that's most often discussed when you're talking about externalities, is a cost that falls on society but doesn't fall on the producer. And again, the classic case is to talk about the cost of pollution associated with producing the good. So, imagine this is manufacturing and they use fossil fuels when they produce. And because of that, there are carbon emissions and it causes, damage to the climate, and you have climate change. So there's an additional cost. And again, absent any sort of regulation, so I would call this one, there's no reason to expect that the producer is going to bear that cost in any way, right? The carbon dioxide goes up in the atmosphere, and over time it causes coral bleaching and more extreme weather. And, around here, a lot of people think that the frequency of the wildfires is being influenced by climate change. I don't know if you guys remember about those poor folks in Paris that their whole town burned down up north about a year ago. Maybe it's 2 years now. But so obviously, if this is a coal-fired electricity, power plant, those are some of the biggest carbon emitters. They don't see, the cost of somebody's house burning down. And again, the way that carbon mixes in the atmosphere to produce climate effects, it could be a coal-fired power plant in China that contributed to global warming and caused in some respect, right, the homes to burn down in California, or I guess it was Paradise, not Paris. But the point is that the producer will never see that on their balance sheet, but it's still a real cost that society has to be concerned about. So where is the externality here? Well, this marginal social cost curve, because it's the marginal social cost, it includes both private costs and any external costs. So I'll just put marginal private cost plus the marginal external cost. And on the diagram, you can see this that way. And remember, this is a sort of thing, it looks a lot like a tax that's being levied on producers, and that's intentional, right? But that distance that which would represent the shift, that is the magnitude of the external cost on a per unit basis. So maybe this will help. So that is the marginal external cost in the diagram. Okay. And then again, if we assume that there are only marginal private benefits to be considered, right, then the demand curve also represents the marginal social benefit in this example. So I'll go ahead and modify this a little bit. So and then where these two curves cross, this is our Q double star. Okay. So this is a classic case where we show that the efficient quantity is less than the price taking equilibrium quantity or the competitive market quantity. And then hopefully everybody here can see that, and this is maybe a little bit more difficult, but that there's a deadweight loss associated with over producing the good in question, and we can talk about that a little bit more in a minute. But so let's go ahead and so this is going to be the equilibrium price, right? And again, so there's our P star. And then we can divide everything up into consumer and producer surplus, and that's all well and good. But if we go ahead and do that, we'll be ignoring the costs that are the external costs that are associated with what should be the net social benefit. So we can count up, producer surplus plus consumer surplus, but we should also take off, right, our external cost. So, okay, so everybody should be able to see that just fine. And the diagram's getting a little bit complicated here, but I'm gonna get rid of that particular line. And then you say, okay, well, it's the case that we're overproducing. So now I'm gonna change this. Say, okay, we're overproducing relative to what's efficient. So, where exactly can, we see the deadweight losses that are occurring and stuff like that? Well, at this point in time, if you're going to try to calculate the net social benefit, then this this supply curve, the private cost curve, doesn't really matter for our analysis, right? We're just trying to calculate the net social benefits, right? And then hopefully now we can see, pretty clearly that this area over here, and this is contributing to net social benefits, right? And this is detracting the area over here. And so the difference between those two areas would be the net social benefit. It would be the combination of producer surplus and consumer surplus that are left over once we correct for the external cost. Now, if you were paying close attention, you would also be able to see that, well, there is a way that we can calculate the total external cost, and it's really because, and I'll put the supply curve back in the diagram, the private cost curve back in the diagram. Okay, it's because we know this difference between the supply curve and the external cost, the difference between the marginal social cost and the marginal private cost of supply curve is the external cost, right? So we can then, if we wanted to calculate the total external cost, right, just like calculating the revenue, but from a tax, in this case, we'd end up with this rectangle that says, oh, for all of these units, right, that you produced, you had this, and I'm gonna get rid of some of these other highlights here. For all these units that you produced, you had this per unit, which is what we mean by marginal. You had this per unit cost in terms of pollution, and you paid that for all the units that were produced in the price taking equilibrium, right? So you're bearing all of this external cost, right? So the difference of those two little areas that I highlighted before, the blue and the red one, that's one way we could calculate the net social benefits. But we could also, from the price taking equilibrium, we can, add up all of the consumer surpluses we normally would, add up all the producer surpluses we normally would, and then we could calculate this external cost and subtract it off. So, that's one way we could do it too. Does anybody have any questions at this point in time? Questions? No. Okay. So now, how do we generalize this kind of situation? Well, remember again, the the efficient quantity, right, which is Q double star, happens where marginal social cost is equal to marginal social benefit. Well, it turns out, right, that marginal social cost has these two components that we're interested in: the marginal private cost plus a marginal external cost. And the marginal social benefit has two components too. And again, on this diagram, we just only emphasized the case where we had an external cost in production, but that's not the only case. Generally, we can have marginal private benefits and marginal external benefits. So this is the case that you probably heard about in principles, or if you paid attention to the lecture that I circulated. External benefits, or positive externalities, sometimes they're called, are situations in which, again, instead of the people throwing off pollution, which is damaging to others, they're doing something that has a third-party benefit. And we already talked about it, but in the case of production, R&D spillovers are one case. Apple produces a new technology, and that helps other firms reduce their costs of following along and competing with Apple. So research and development spillovers are one case. Another case is often talked about, has to do with getting vaccinated. So when somebody gets vaccinated, they're less likely to pass the disease to other people who aren't vaccinated. So they create a benefit for society more generally, for other people. So combining these two equations, we can say, oh, okay, so the efficient quantity happens where we have, and I'll just try to copy this to make it a little bit quicker. This condition okay. And if you read in the lecture, and there's kind of a like hint here I talked about already, one of the ways to restore efficiency to a price-taking equilibrium or a competitive market when there is a negative externality is to introduce a tax called a Pigovian tax. And a Pigovian tax is a tax, in this case, it doesn't really matter if we levy it on buyers or sellers. We found that out with taxes. We could put it on either the demand side or the supply side, and our equilibrium would be the same. But we can pick a tax that's equal to the size of the marginal external cost, and then end up with a shifted supply curve that would get us right back to the efficient quantity. So that's called a Pigovian tax. And a Pigovian tax can correct the price-taking equilibrium tax is equal to the marginal external cost. Okay, so that's, and this is kind of an important thing. So we have, when the first fundamental welfare theorem breaks down, then what a lot of people like about this material is it actually shows a constructive role for government. Normally we have this outcome that, well, taxes are just bad, they cause deadweight losses. You know, the government's introducing efficiency with price controls. The government is bad, bad, bad. But here there's this argument that no, the government can actually play a constructive role in regulating externalities by introducing taxes and getting us back to an efficient outcome. And also in the case of where we have market power with monopoly, you can, see that the government could do a constructive thing by, reducing the market power so that we move from something that looks like a monopoly to something that looks more like competition, and again, increase the efficiency of the situation. By the way, can anybody tell me, have you all been reading the news? What's a big example of the government trying to correct market power that's happening right now? Nobody? Does anybody know? Well, how's this? Where are we most concerned about market power right now? Okay. No Green New Deal. No, Michael. That's not. It's not China. So Ben's thinking electric cars. Okay. Well, I'll tell you all. Steven says the housing market. Okay. So I'll tell you all. I'll give you a hint. Remember, it helps to think this way, right? Market power is monopoly power. What are the monopolies that you guys are concerned about right now? Or what might be monopolies? I mean, whether they're actual monopolies or not is the whole. You think you worry about monopolies in gas? Okay. Anybody else? Okay, another hint, right? Where does it seem like there are huge firms that are dominating industries? How about Amazon? How about Google? How about Apple? Yeah. So right now, the U.S. government is suing Apple because there is an argument being made by app developers that Apple is making monopoly profits off of what they're charging to download apps from the Apple store, particularly the developers of. Has anybody heard of Fortnite? Does anybody play Fortnite? I've never played Fortnite, so I don't even know if it's a good game or not. I'm Call of Duty all the way. Well, yeah. So Microsoft has been sued several times by the U.S. government, but these are what you would call monopoly enforcement actions under the U.S. Justice Department's antitrust division. But yeah, so the developers of Fortnite and the U.S. government are suing Apple because the Fortnite developers are arguing that Apple has created a closed ecosystem in which they can behave like a monopolist and charge what are I'm going to use a word I don't like to use, but just to convey the point, they're charging unfair fees to app developers. Yeah, and the way that they're doing in-app payments, and that's being run by Apple, and it's unfair competition. Let's just say it that way, and they've created a monopoly in the App Store. So whether you agree with that or not, it's something that's being debated in court right now, and yeah, so and the government has a role in trying to create a competitive market so society can have the benefits of an efficient outcome. Consumers don't have to pay too much. The profits are distributed amongst producers in a way that's fair. But anyway, the main point is that, yeah, right now a lot of people are concerned about big monopolies in high tech, and one of the other ones that was mentioned, because Benjamin said he was worried about electric cars, I think, is that people have mentioned Tesla in that list too, though I think that there's a pretty good case to be made that Tesla really doesn't have anything like a monopoly, because there are lots of other car brands that are moving toward really high quality electric vehicles that are going to compete directly with Tesla. So, but yeah, people are worried about it in high tech. So, but yeah, whenever you have a monopoly problem or an externality problem, there is a constructive role for government in its regulation, at least from an economic perspective. The role is constructive because you can argue that the government could actually increase efficiency, increase net social benefits, increase total surplus, not cause deadweight losses. Okay, so this last line here is our general way of expressing what the efficient quantity is in a situation that could have both external costs and external benefits, right? Remember, external costs and external benefits are just costs and benefits that go to third parties, meaning not either the buyer or the seller. So you can imagine a situation where, for example, there's a vaccine, right? And the vaccine creates this external benefit, but in producing the vaccine, the factory generates pollution. Maybe it's carbon emissions, maybe it's other things. So you could have something going on the cost side and something going on the benefit side, and then your diagram and your comparison, everything gets more complicated. And we don't. These situations are discussed in the video, so I'm not gonna rehash those. But I just wanted to point out that it's a more general framework, and in particular, a lot of students get sort of hung up on the idea of, and it's not necessarily something that I don't understand, right? It kind of makes intuitive sense, but so for example, something like, and I'll try to move this a little bit and draw a little diagram. So for example, you start out with a simple situation like this, and this is like the situation that I just graphed, where you have a marginal private benefit and you have a marginal private cost. And then you say, oh, okay, well, the producer's creating the pollution, so I'm just going to add on the external cost here, and then I'll get my marginal social cost curve. Okay, so that's just like what we did before. And that makes good intuitive sense in these sort of simple situations. There's nothing wrong with that. But what if it's not? So let's talk with somebody. Arslan, how about you? You're good for conversation. You there?
Yeah.
Okay, so let's imagine another situation, right? So it's not a manufacturer that's generating pollution coming out of its smokestacks, right? But let's say it's a cigarette manufacturer, right? Have you heard that secondhand cigarette smoke damages the health of non-smokers that are exposed to it?
Yeah, I have.
Yeah. So, but in that case, right, the tobacco producers are making the cigarettes and they're selling them, right, to a consumer. And it's in the act of consumption, when they light up the cigarette, that they're damaging the health of third parties, people nearby, right? Where should we put that in the diagram?
I see what you're saying. Yeah, it's not the firm itself, but it comes later through the consumer.
Yeah, it's a definitely an external cost, right? Because it's damage to the health of non-smokers, right? They don't buy or sell cigarettes, right, in our scenario, but nonetheless, they bear this cost of people consuming cigarettes. So where should I put that in the diagram?
You don't, I guess.
Well, no, I mean, we should, right? Because it's still an external cost if we want to find the efficient quantity. But my point is that it's just an external cost. That's where you don't want to get hung up. You would just do the same thing. External cost. Does it matter that it's not the producer that caused external cost? No, it doesn't. So don't let the algebra guide you, right? You see what I'm saying? Let the algebra guide you, and don't worry that, oh, it's not like everything that happens on the supply side is the producer's fault or responsibility. We're just graphing curves here. This is still the marginal private cost curve. This is still the marginal social cost curve. That's still marginal external cost. It doesn't matter that the damage to the third party is happening when the good is consumed as opposed to produced. All we're trying to do is find the efficient quantity. So we've accounted for all the costs properly. Do you see what I'm saying?
I follow you. Yeah, I guess I have a question, but maybe it's a bit of a tangent. We can get to it at the end. But
Okay, well, I'll just extend this really quickly, and then maybe you can ask your question. So likewise, right? There's if instead of doing this, right, um, you know, and we'll talk about two other scenarios, and then I'll be done with this. Okay, so let's talk about external benefits, right? So you think about somebody. Does the government give a benefit to companies providing the marginal external like that? Yeah, so the government, and again, this is talked about in the lecture, Joshua. So you can have Pagovian taxes, and you can also have Pagovian subsidies. The government, and that's the main point here. The government has a role in regulating externalities by introducing taxes that are going to reduce the quantity of goods that are associated with negative externalities. One of the so let's talk about another case. I talked about secondhand cigarette smoke, and you know that there are cigarette taxes, right? Well, it's also true that one of the justifications for alcohol taxes is that there's a big negative externality associated with alcohol consumption. Can anybody tell me what that one is?
Drunk driving.
Yeah, people drink. If they drink too much, right, they get out on the road, and they're not just a hazard to themselves, but they're a hazard to other people. So and again, that's something that happens in consumption, and we could graph it the same way here. But so let's talk about external benefits. I gave you guys the example of vaccine, right? And you could say that somebody gets vaccinated, and when they get vaccinated, they're consuming the vaccine. It's not when the vaccine is produced, it's when the consumer actually gets injected, right? And in that case, right, we would be over on the benefit side, and we could add in an external benefit, and now we have a new marginal social benefit curve. And so, Arslan, can you see where Q double star is now?
Q double star now.
Remember, Q double star is the efficient quantity, right? Our private equilibrium quantity, the price taking equilibrium, is always where demand and supply cross. But we're now in this situation, right? Marginal social cost equals marginal social benefit. The private costs are the only costs to consider because we don't have any external costs. So just get rid of that. So our
So it's
supply
where,
curve.
yeah, the new marginal external benefit curve hits the.
Well, it's the marginal social cost curve. Remember, the only
Yeah.
the only external benefit is it is represented by just this shift right here, right? Is that clear? It's just the shift up that
Okay,
is
yeah, I'm
the
following you.
external benefit. So only that part is the marginal external benefit, right? So our Q double star is where, again, and I could label this, now this is the marginal social benefit, that's marginal private benefit, and this is the marginal social cost curve, because there is no external cost. So the MEC is zero, right? In that case, if MEC is zero, right, then MSC is equal to MPC. Do you see what I mean, Arson?
I'm following you. Yeah.
If that's zero, so labeling the supply curve, the MSC is fine. And then where they intersect, that's going to be the new, and we call it the efficient quantity. You could also call it, and it's often called, so Q double star is also called socially optimal. That's fine. You can call it socially optimal quantity, but yeah. So this sort of situation where there's an external benefit, right? So this gets back to Joshua's question. You could, again, create a subsidy, right? And a subsidy, a tax, either, increases supply or decreases demand, but a subsidy is just a negative tax. It works in the opposite direction. So if you create a subsidy, which is the government giving money, right, instead of a tax where the government's taking money, the government's giving money equal to this marginal external benefit, then you would have a Pigovian, and I'm just going to subsidy. Do you see, Joshua? Okay. So, and what about you, Arslan? Do you have any questions?
So the Pigovian subsidy is equal to the marginal external benefit. Like that is the external benefit.
Yeah. That's by definition. Whenever you say there's a Pigovian tax or a Pigovian subsidy, the thing that makes it Pigovian is that it's equal to the size of the external effect. Does that make sense?
Yeah.
Yeah. So like when we talked about taxes on alcohol and cigarettes, for example, there's a justification for taxing alcohol and cigarettes because of their external effects, that it can actually make the economy more efficient. But in general, there's no good evidence that the size of those taxes is actually matched or proportional to the size of the external cost, right? So I won't say that legislators set those taxes randomly. There are people in California, for example, the California State Department of Finance, that are economists that do benefit cost studies that try to figure out and I'll just say this in air quotes, what's the right amount to charge for, these, and they're called sin taxes because people used to think that drinking alcohol, maybe some people still do, smoking cigarettes, that those were like sinful things to do. So they wanted to discourage those activities. But um, but just because there are taxes on them doesn't mean, and because economics says that, it's it's efficient to have some tax on those negative externality generating activities, doesn't mean that the tax is actually a Pigovian tax, because it would have to match exactly this magnitude. And again, the State Department of Finance has other issues other than matching up the size of the tax with the marginal external effect to ensure that the market's efficient. So yeah, they're taxes on these negative externality generating activities, but they're not necessarily Pigovian. Does anybody have any questions right now? Okay.
Actually, yeah. On the other graph you were just showing us with the external cost.
Yep.
So is that external cost, would that be equal, like the change, would that be equal to a Pigovian tax?
Yeah.
Okay, in the way on the flip side, then that was a Pigovian benefit.
Yeah. So this is like the comment down here.
Got it. Thanks.
Right. Yeah, exactly. So this is like the general thing. Now to be a little bit more sophisticated about this, I mean, so we told the story again where this is the vaccination case, right? I went and got vaccinated, and so and you guys know this is a really great situation given that we're in coronavirus times, right? Great example, because there are people out there that for various reasons are resistant to getting the vaccine. Our vaccine distribution has slowed down a lot in the United States. And I'm not going to say whether being resistant to the vaccine is a good idea or a bad idea. It's just the point that it is, right? And so surely people like me who've gotten vaccinated are conferring some benefit to those people that aren't getting vaccinated for whatever reason. And that's in my consumption decision, my decision to consume the vaccine. I generate this benefit. So this is the graph. But if instead we were dealing with, again, a case where there's an external benefit created, suppose that instead, this was a high technology good and there was, information spillover through research and development that, as I said before, helped other producers and things like that. This could still be the graph and it would be fine. We can just put the benefits from whatever the source, right? Whether it's from consumption or production on the benefit side of the graph, and we can put the cost on the cost side of the graph. And our thinking should be clear. It doesn't matter whether it happens in consumption or production. Okay. But notice that the only thing that really matters is our algebra. Okay. So there's nothing wrong with rewriting this and saying, oh, I'm going to have marginal private cost equal to marginal private benefit plus marginal external benefit minus marginal external cost. So do you see what I did, Arslan? This equation is the same as that one.
Yeah,
It's gonna identify the same Q. I just moved marginal external cost over to the right side, And now I have kind of like this, what you might call, a net external effect, because I could just write it this way, right? I could just put parentheses there. A net external effect, I don't know if it's going to be a positive or negative, right? But just stacked up on the benefit side. Because that's the marginal private benefit. So that's on the demand side. You see what I mean, Arslan?
Yeah, I follow you.
Yeah. So, and the reason why I point this out, I just have two other things that I want to say about this. One is, so let's talk about, a lot of people have argued, and it's really interesting because I think it was, who was it that brought this up? Oh, Michael Quintana, right? How are you doing, Michael?
I'm all right.
Okay. So there are a lot of people, and so check this out, okay? So here is the demand for gasoline, okay? And here is the supply for gasoline, right? Can you think of any external costs associated with gasoline? Michael? Okay. Well, I said externalities, right? So the
Like cost to the
gasoline. Okay, who is that? With Miles?
environment.
Yeah, don't you jump off really quickly, Miles. You could probably just tap because you want to talk. But talk to me, Miles. Tell me about this. Explain all the damage that fossil fuels do to our environment.
What do you mean? Like,
Well, yeah. I mean, like you know that there's environmental damage, but can you put some detail in there? What is it? What happens?
it reduces like a bunch of like gases that like go in the atmosphere and like the greenhouse gas effect and like increases our temperature, right?
Yeah, so that's one source, and it also turns out that fossil fuels are responsible for a lot of pollution locally, not just up in the air with carbon dioxide, but they generate nitrous oxide and carbon monoxide and all these things that actually damage the health of people who are around the cars immediately after the gasoline's been consumed. So, in fact, I've done a lot of consulting for the South Coast Air Quality Management District, who has a big district headquarters that's right near Cal Poly, and yeah, I mean, regulating fossil fuels is a big issue, not because of greenhouse gas stuff so much, but because there are people that every day in Southern California, there are higher rates of asthma attacks and heart attacks because of poor air quality, especially in the summer. That's when it gets the worst. But anyway, so we could go ahead and put in our marginal social cost curve. I'm not going to draw the size of the externality because I already did that. And then we could compare and say, oh, okay, if there was no regulation, we would have this price taking competitive quantity, and we should actually, right, if we're going to balance marginal social costs and marginal social benefits, we should have a much smaller quantity. And sure enough, right, we know that we end up with a smaller quantity, right? That's socially optimal. But okay, what I want to also point out, and this is to your issue, Michael Quintana. Now, if this industry was monopolized, right? So I'm going to get rid of this because only the quantities matter, right? You can see there's a competitive quantity Q star and then Q double star, right? Well, and now I'm just going to get rid of this from the diagram. It doesn't mean it's not there. It's just that I want to emphasize the monopoly outcome, right? For a monopolist, right, we would set marginal revenue equal to marginal cost, and then we get a monopoly quantity, right? So this is Q double star, but it's also the case, and we know the monopoly quantity is smaller than the competitive quantity, but it's the case that the monopoly quantity might actually be efficient when, and obviously it depends upon the magnitude of the negative externality, but the point is, we know monopolists earn monopoly profits by holding back production to drive up prices, right? Well, in the case of fossil fuels, that might be exactly what we want. And this is an example where you could argue, as lots of people have, that the monopoly might actually not be associated with a deadweight loss. If it turns out that, as I've illustrated here, that Q double star is equal to QM, that's all that matters, because Q double star is by definition efficient. Does that make sense, Michael?
Yeah.
Yeah. So monopolies in some contexts might be, and I'll put it in air quotes, a good thing. So what do you think about that, Arslan?
Monopoly being a good thing?
Yeah.
My gut tells me it's wrong. I don't know better, I suppose.
Well, just remember that if we're only concerned about efficiency, and that's the only, thing that we are concerned about as economists, right? If it turns out that the monopoly is efficient, there's no economic argument for not keeping the monopoly. It's just the thing that's causing the monopoly to be efficient in this case is there's an externality that's present. It's not in the diagram anymore, but that means that no longer is the competitive quantity socially optimal, but some amount less, and the monopolist produces less, so it's fine.
That makes sense. It's kind of going back to what we did at the beginning of the semester, where you said the first fundamental welfare theorem, in a way, kind of does say monopolies are efficient.
Well, so the first fundamental welfare theorem tells us that competitive markets are efficient, right? But only when there's no market power, no externalities, and there's symmetric information. So monopolies in general, right, if there are no externalities, they'll be inefficient. But if there are negative externalities, it's possible that the monopoly could be efficient. So yeah, and that's just because the monopoly is just one mechanism for reducing the quantity of the output that's generating that external cost. So it's a special case, and it's also kind of interesting because, the first fundamental welfare theorem, remember, tells us, and I don't know where I had it here. Oh, yeah, so it's up here. So, but the first fundamental welfare theorem tells us that basically, competitive markets are efficient, but they're only efficient if, right, open marks, efficient if, right, no market power, no externalities, and symmetric info, right? That's the first fundamental welfare theorem, like in a nutshell, right? And this is other initiative. Okay. So, but the interesting thing here is that, so if I break one of these, I have just a monopoly and not the other ones, I get inefficiency. If I have just externalities and no market power and symmetric info, I you know, generate inefficiencies. I generate deadweight losses. If I just have a problem with information, I'll generate deadweight losses. But here's a case where I break the externalities and I break the market power at the same time, right? And voila, I get an efficient outcome. So, you know, the first fundamental welfare theorem is tricky in the sense that it tells us how to guarantee efficiency, but there are cases where you can break it really badly. You can have externalities and market power, but you can still have an efficient outcome. So that's, you know, just something to be aware of. The last thing that I wanted to say on this subject is here. Okay, so if, for example, right, you were given a question and you were asked, oh, okay, let's have an externality, and let's also have a monopoly, and then you know, do something like introduce a tax that's appropriate to correct for the externality. Well, gosh, then we've added in, you know, like a lot of things. Well, you have choices at that point in time, right? And so you could choose whatever alternative was easiest, right, to try to predict the outcome. So the only thing I'm going to do is I'm going to say, okay, let's just suppose and you know, that we're going to introduce a Pigovian tax into a monopoly situation. And I mean, so for example, let's suppose that our Q double star was way back here. It should be even smaller than what the monopoly outcome is, because the monopoly outcome is always going to be where our marginal revenue intersects with our marginal cost, right? Then the question is like, well, you know, what's a big enough tax to impose on the monopolist so that the monopolist will actually get us down to Q star? Well, again, this gives me a guide, because I can say, well, in this sort of a situation, I just have to add in a big enough tax such that I induce the monopolist to get me to Q double star. And so I shift up the private cost curve by the amount of the tax, and then I'm trying to just illustrate this. So it looks like to me this tax should be a little bit bigger to get me to Q double star. Okay. I'll move it a little bit more that way. Okay. So now I can look at, you know, what's the appropriate corrective tax in the case of a monopoly, if I know. And what's hidden behind the scenes here is that this Q double star is actually where I'm balancing the, well, I guess maybe this equation is the best one, where I'm balancing the marginal social cost against the marginal social benefit. So I could draw another diagram maybe down here and show you that Q double star is actually where marginal social cost and marginal social benefits cross. And so I can induce the monopolist to get there. And it would be a different magnitude of a tax than if the firm was competitive. So anyway, hopefully that gives you a little bit of a taste of how we can use these types of equations. Okay. Does anybody have any questions? No. Okay. So I'm gonna go ahead and